Hi everybody, welcome. Today we're going to look at an exciting topic, pushing boxes. And we're going to focus on the contact force between those boxes. So our setup is we have a 3 Newton force applied to a 3 kilogram box and a 12 kilogram box. Every time you have multiple objects, always start by looking at the system. So we're going to start by looking at the system. And so my system in this case is both boxes. So I have a 3 kilogram box and a 12 kilogram box. So really I've got a big 15 kilogram box pushed with 3. And so if I think F net equals ma, my F net is 3 newtons. My mass is 15 kilograms times my acceleration. So my acceleration is 3/15, which is 0.2 meters per second squared. And so once you have that acceleration, we're now going to use it. So here we go. I need to start off by drawing the small box. And I'm going to draw my big box. Small box, normal force, weight force, pushed with 3 newtons. Big box, normal force and weight force, and it doesn't get pushed with 3 newtons. So now we get to play. So this front box feels a force on the big box by the small box. This box, the small box, feels a force backwards, force on the small box by big box. Now we have to figure out how big those are. We called these things right here, the black arrows, our contact force. And so what those are is the force that they feel between them. So let's find those out. So to find those out, I need to find those out. What I need to do is I need to find my F net for each of these. So the F net for this guy is ma. The F net for this guy is ma. His mass over here, the big guy, is 12. His acceleration is 0.2. So his F net is 2.4 newtons. So if I think about it, if my F net's 2.4 and this force here is the only one that doesn't get canceled out, how big is it? 2.4 newtons. So what's the answer to my contact force? 2.4. I'm done. But let's say you're a glutton for punishment and you decide to do this one over here. The mass is 3, the acceleration is 0.2, so the F net is 0.6 newtons. Uh-oh, Schmear. This is not good. Or is it? So it's getting pushed with 3, but it only has, look down there, it only has a net force of 0.6. So if it only has a net force of 0.6, that means that this guy backwards, right here, needs to be 3 minus 0.6, so it needs to be 2.4 newtons. If you look, those are the same. So now, what I would like to do is give you a chance to try on your own. Pause it, solve it, determine the contact force. So the contact force is going to be 0.75 newtons.